So the first thing we're looking at is arithmetic. So sequences and series. A sequence is just a pattern that occurs. In an arithmetic one, you have a common difference in which you go from one number to the next. So for example, -3, -1, 1, 3, 5, what's the next number? 7, 9, and so on, right? So the common difference in this case is 2. Okay? So that's all that an arithmetic sequence involves. That there's that we're working with. So you're going to work just today basically on examples using arithmetic sequence. Now an arithmetic sequence in terms of graphing is going to be a line most times. Okay, you're going to consistently go up by the same amount. So if you were to graph it, you would end up with a line. So look on page 2 and we'll look at the first question here. Okay, just before I do that, I'm just going to give you this right now. So make a note of this. To find any term of an arithmetic sequence, you need to know the first term, and you need to know the common difference. So this will allow you to get any term of an arithmetic sequence. Now, if I just looked at this and I changed this around a little bit, this here would be my y-intercept, this here would be my slope. Okay? So when we start looking at it, that's what, or sorry, the d will be my slope for it. But that's what it's going to look like if we were to graph it. So an example of that question, okay? A construction company hires a plumber to install pipes in new homes. The plumber will be paid $65 for the first hour of work, $110 for 2 hours of work, $155 for 3 hours of work, and so on. State the first 3 terms of this sequence. Use these terms to determine the common difference. Then use this information to state the next 3 terms of the sequence. Okay, so the first term of this sequence is what?
65.
65. Term 2 is
110.
110, and term 3 was?
105.
Okay, so how much is it going up by?
45.
45. So that means that our d then is a value of 45. So what's the next one? What's T4 then?
200.
200. T5?
245.
45. T6?
290.
290. So that's good. Okay, so that's pretty straightforward so far, right? Okay. Now, to find any d value, you take one term and you subtract the term that comes before it. So either term 2 subtract term 1, term 8 subtract term 7, term 9 subtract term 8, doesn't matter which. So I can take any of these terms and subtract the one before it, and I would end up with my d value. So for example, I'll take term 5, which is 245, minus term 4, which is 200, equals 45. Okay, so it's not that tough. So as I go through, in this book, you should fill it in as you go along. Okay, so d is equal to T2 minus T1, which is equal to 110 minus 65, which is equal to 45. The next 3 terms are T3 plus D, which is, what's term 3? 155 plus 45, right? Which is equal to 200. T3 plus what times 45? This is an interesting one. 2? Yeah. 2 times 45, which is 90. 90 and 155 make 245. Okay, so that's fine. We'll just keep going now. Now, write the general term that you could use to determine the pay for any number of hours worked. All right, so here's the interesting thing. Okay, the general term always involves t to the n. So you're going to write it up. So when we had something similar to this, was graphing a line and writing out the equation of a line. That was allowing us to get the general term for the line, the graph. So if I wanted to find any y value on the graph, I would substitute an x value into that equation and get the y value. So that's considered a general term. So to find the general term in this, I need to know what my t to the 1 is, which is 65. This stays as n minus 1 because it just shows that I can put any term in here. And I times it by my d value, which is 45. Okay? So that's the general statement to find any term in this arithmetic sequence. So then the next question is, how much does he get paid if he works 10 hours? So I want the 10th term. So how do I find that? 65 plus 10 minus 1 times 45. Okay? So what does that equal? Where's your calculators? Never mind. You're good. 450, 490. What's that?
Oh, never mind. Okay.
490. Okay? Now, they do simplify this a little bit. So I'm gonna make it, I want to change this. And the reason they simplify this, so take a look at this right here. This general term, they actually simplify it so that it ends up, we multiply the 45 through and we simplify it. Okay? So it looks like this. T to the n is equal to 65 plus 45n minus 45. Okay? So I multiply the 45 through the brackets. Equals 65 plus 45n. Now, oh, sorry, this should be a 20. I'm gonna rewrite that. So that's 45n plus 20. So now when I look at this equation, there's my slope, there's my y-intercept. Okay? If you were to therefore graph it. Did I do that wrong? So this should be 470, not 470. Okay? And this is an arithmetic sequence. So that's pretty straightforward. Any questions? Okay? Again, this is our focus on that general statement at the top there. So each time you do one of these questions, you somehow have to find T1 and you somehow have to find D. Okay? Working example 2. A farmer decides to plant an apple orchard. She plants 24 trees in the first year and 15 apple trees in each subsequent year. How many years will it take to have 204 apple trees in the orchard? Okay, so we'll follow the book's way of doing it and then we'll discuss it. The sequence is arithmetic because the terms in the sequence have a common difference of what? 15. So D is equal to 50. What's the first term? 24. And the nth term, which we don't know which term it is 204. So I start by writing out my equation. T to the n equals, okay, T to the 1 plus n minus 1 times D. What is my T to the 1? 24. 24. What is my D? 15. And my T to the n is 204. So we just substitute it in. 204 equals 24 plus n minus 1 times 15.
So you're ever gonna have to put anything in for n minus 1?
Yeah, that's what I did right here. For 10,
Oh, okay.
I substituted in for n. When I'm looking for an actual value, I substitute in that.
Okay.
Okay, so now what do? I need to solve for n here. So what do you want to do first? Could, okay, I wouldn't have, but that's fine. It's going to work this way. I'll explain what I would have done before, but that's okay. Good? Okay, so I've done that, I got rid of my brackets. Now what?
Common factors or whatever, so take away 15 from 24.
Okay, so we got 204 equals 9 plus 15n.
Subtract 9.
Subtract 9. 95 equals 15n.
25 by 15.
Right. N is equal to 13. Okay, right on. Okay, I would have done this different. I would have subtracted the 24 first, and then divided by 15. Okay, still gets the same result as you, but I wouldn't have gone through the brackets because it added about 2 extra steps, but not wrong. That's fine. Get rid of your brackets if that's what you used to. Get rid of your brackets first, and then do it. But in this case, I would have subtracted 24 to get to 180, divided by 15, and then added the 1. Okay? It's all right. Pretty straightforward as well. Okay, so there is a way, this again is not very tough. So there is a way, there is a part of this. The next one is where it's a little more complex than what we've been doing here. Okay, so let's look at example 3. Girls done with this? Okay. An amphitheater has 25 seats in the second row and 65 seats in the 7th row. So T2 is equal to 65. T7 is equal to, what was that missed?
T2, 25.
T2 is 25. Sorry. And 7 is 65, right? Yeah. Alright, perfect. Okay. So now the question says, how many seats are in the first row? Oh, sorry, in the last row, which we don't know how many T to the N is, 209, right? Okay, so the first thing it asks you is how many seats are in the first row? Okay, so I'll show you the method that they use, all right? And then I'm going to show you a different method that I would use, okay? Because we've done this already in applied, so I'm going to show you both ways. So the first way is this. We have 1, 2, 3, 4, 5, 6, and 7. 7 rows so far. In the first row we have 25. In the 7th row we have 65. Okay? To get from here to here, I have to add D's because there's a common difference. We know it's an arithmetic sequence. It's a common difference. I got to add 1D, 2D, 3D, 4D, and a 5D to get to that point. Okay? So therefore, I go 25 plus 5 D's is equal to 65. Does that make sense?
So what is these 4Ds?
No, because I add 1 D to get to here.
Oh, okay.
I add a second D to get to here, a third to get to here, a fourth to get to there, and then the 5th.
Okay.
I should have put these in between, and then that might have made more sense. Okay? So I've got this. So now what? Solve for D.
Take away 25 and divide by 5.
Right. So 40, that means 8, right?
Yeah.
Good? Good so far? So how do I find out what T1 is then?
Subtract 8.
25 minus 8.
25 minus 8, so T to the 1 is?
17.
What is it, sir?
17.
17. Good. All right. No problem so far? Okay. Now, I said I'm going to show you a secondary method to this. This is the method I prefer because you're going to see when we do geometric sequences, we're going to use one very similar to it. So I'm going to do it this way. Okay, so what I'm going to do is I'm going to write in my information into my general equation. So T2 is 25, right? Actually, I'm going to start with T7. So I've got 65 is is equal to t to the 1 plus, that's the 7th term, right? So I have 6d then. Okay, so far? So I just substituted into my general equation, t to the 1 plus n minus 1 times d. All right? The second term is 25, and it's 1d. Right? 2 minus 1. Okay, so far? Anybody have any problems with this? Draw a line and I'm going to subtract the 2. Okay? What's 65 subtract 25? 40. T to the 1 subtract t to the 1? 0. 6d subtract 1d?
5d.
D is equal to 8. Okay? So what I do is I write the term, and I didn't have to do it this way. I always write it as the larger term on top and the smaller term on the bottom. I would have ended up with negatives if I had to flip them, but I would have had a negative divided by a negative, and I still would have ended up with the same answer. But to me, I always write the term that comes last on top and the term that comes first on the bottom.
So that part doesn't matter then?
No. No. Okay, and then I would have subtracted to get t to the 1. Okay? All right, so I'm at this point. So now we want to find out what term t to the n is. We want to find out what term it is. So how do you propose I do that?
Times your t1 by, plug it into your general formula.
Okay, so it's going to look like what, Case?
209
Yeah.
Is equal to 17. Sorry, I just kind of lost the formula.
N minus 1.
N minus 1, and then the d of 8.
Okay. So how do I solve that now?
Subtract 17.
Subtract 17.
Divide by 8.
Divided by 8. What is that?
24. And then add 1.
5 rows. Okay? Any questions? All right. This is the easy guy. Page 14, we have arithmetic sequences, series. So the difference between a sequence and a series is a series, in a series, we just list out our terms. Okay, sorry, in a sequence, my bad. In a sequence, we list out our terms. That's what we just did. In a series, we add the terms together. So, s to the 1 in this case is minus 3. S to the 2 is minus 3 plus minus 1, which is minus 4. S to the 3 is minus 4 plus 1, which is minus 3.
And then 0.
S to the 4 is equal to 0. S to the 5 is equal to 5. This is what we're going to do tomorrow. Okay. So for today, all I need you to do is just finish up, start and finish that arithmetic sequence material, okay?